implicit differentiation. Okay, now let's say we have a function and you want to differentiate the function with respect to x. This is y. You want to differentiate with respect to x. Okay, so you differentiate with respect to y first, then you put dy dx. Okay, so differentiate y with respect to x, you put dy dx there. Differentiate as usual, then you put a dy dx there. Now this is a function involving x. You want to differentiate with respect to x. So just differentiate. Don't add anything there. Because x with respect to x is okay. Right? No need to add anything there. It's a function involving t. And you want to differentiate this function with respect to x. Right? So differentiate as usual, but you put dt dx and dt dx. Okay, so now I ask you, okay, there is a function, let's say 3y plus 2x. Okay, this is a function. Okay, I ask you, differentiate with respect to x. First one, differentiate with respect to x. Then second case, differentiate with respect to y. So two questions. Can you do on a piece of paper and show me what is the answer?
Mm.
No, this is not the answer. It's not the answer. Okay. So I show you how to do it. Oh, this one. If you want to differentiate 3y with respect to x, differentiate 3y is 3. Differentiate 3y is 3. But then this is y. You want to differentiate with respect to x. So you have to put there, you differentiate y with respect to x. Okay. And this one, differentiate 2x with respect to x. Or because this is x with respect to x, you just differentiate. That's all. So this is the answer. So answer is 3 dy dx, because y, you have dy dx. This one, 2, no more anything differentiate. Because x with respect to x, you don't have to add anything there. You show me this one more time.
Mm.
This is correct. Okay, this is correct. Now there's one more question here. I think it's y cube. Y cube. Okay, so now there's one more question. The question is y cube. Question is y cube. Y cube, you're going to do the same thing. You show me how to differentiate with respect to x and how to differentiate with respect to y. Okay? Y cube. Now I have y cube. Y cube. This one I have here y cube. So you show me how to do this. Differentiate y cube with respect to x. Differentiate y cube with respect to y. Okay, differentiate with respect to x, 3y square, differentiate with respect to y, 3y square. This is correct, but the writing is not good. The writing is not good. Okay, I show you. When you differentiate y with respect to x, so this is 3y square. 3 3 3y square. Okay, then you don't put the dy dx in front. You put the dy dx behind. Dy dx, you put behind like this. You don't put in front. Okay, you put behind. This one, differentiate y with respect to y. So it is 3y squared, correct? So your answer is correct, except that when you write the dy dx or the d something, you have to put behind. Don't put in front. Okay, so this is correct. Where is it? It's here. Answer is here. Answer is here. 3y squared with respect to y. With respect to y, 3y squared, you add the dy dx there. Put behind. Now, instead of having this one, they ask, how are you going to differentiate square root of y? Square root of y with respect to x and y. Yeah? Square root of y. Square root of y. It's not this anymore, right? You show me how to differentiate square root of y. I've shown you just now how to differentiate square root of y. Now you show me how to differentiate square root of y with respect to x and with respect to y. Okay, right. So now we're going to differentiate. The differentiation is correct, but you must know how to simplify this. Okay, so how to simplify this? Okay, okay. This one, simplify this. The color is not nice. I want to change color. Okay, right. How to simplify this? Right. The 2 is at the bottom. Right. Y to the power negative half is also at the bottom. So it will be 1 over 2y to the power of half. Once you put at the bottom there, it's no more negative, right? Inside this. Then you put dy dx behind, correct. This is dy dx is correct. And if you want to simplify some more, it becomes 1 over 2 square root of y dy over dx. Okay. The differentiation is correct. Normally, we don't leave it like this. We're going to leave it like this. Okay. Okay. Then the last part, this one is, where is it? Okay, okay. This one is not like that. This one is negative, negative, right? So it will be same thing as this, but without the dy dx. So it will be like this, 1 over 2 square root of y. And this is wrong. This is correct, okay? But you simplify this way. This one is wrong because there's no negative there. Any question?
No.
No, huh? No, then I clear this thing. Clear this thing. Then we go back to this previous page here. Right. Now, sometimes when you do differentiation, implicit differentiation, you will come across xy. Now, xy doesn't mean one function. It means two functions. It's a product of x and y. X multiplied by y. Now, if you want to differentiate this with respect to x, how to differentiate with respect to x? This is the answer. How to differentiate this xy with respect to x? Okay, so I want to show on this page. So I want to show on this page. So I have let's see. Make it thicker. Okay. So I want to differentiate dx. Oh, I want to differentiate dx dx of this x y. Okay. So this is one function, then this is another function. It is the product of two functions. I want to differentiate this, I have to use the product rule. Product rule means I have to differentiate one, then keep the other one. Okay, what is the answer? Differentiate x, become 1. Then the y, I just keep the y. Don't want to differentiate the y. Plus, just now I differentiate the x. So now I keep the x. Then I differentiate the y. Differentiate the y, become 1. But because I differentiate y with respect to x, I have to put the dy dx behind. I have to put the dy dx behind. This is the part we use the implicit differentiation. Right? And we also use the product rule. So simplify 1 times y is y, then x times 1 is x. By the way, where to get the 1? You differentiate y, you get 1. Then you put dy dx behind, right? 1 dy dx is come from this differentiate y, right? So 1 times dy dx is also dy dx, dy over dx. So the answer is y plus x dy dx, x dy dx. Okay, so I refer back to this here. Okay, here. So differentiate the x become 1. Then the y don't differentiate. You just keep the y. Okay. Then next part, you keep the x, then differentiate the y. Differentiate y, you get 1. Because you differentiate y with respect to x, then you have to put the dy dx there. So these two multiply together, you get y. These two multiply together, you get dy dx. Any questions so far? This one?
No.
No. No, then I want to test you, right? I want to test you, see whether you know how to do or not, right? Yeah, this one the one. Okay. Now I want to test you. I use this one. Okay. Now I differentiate 2x square then y. Okay. This time only one question. Differentiate this with respect to x. Differentiate 2x square y with respect to x. I didn't ask with respect to just with respect to x. So you refer to this example here, then you tell me how to differentiate this.
And go just down the page.
Sorry,
And go just down the page.
the one
Just
delete
down
off
the page.
already. The one is
Huh?
use the writing one. Use the tools or delete off already. The one all now become blank already. They all become blank. You refer to this one. This one. Differentiate the first one, keep the second one. Keep the first one, differentiate the second one. You refer to this. Okay, let me see. Differentiate the 4x to x. Oh, this one. Okay, let me explain. Okay. Now, you separate them into two functions, one like this, one like this. So the first one, you differentiate this, you get 4x. You are differentiating x with respect to x, so no need to write anything. Then you keep this y, so this one is y. Okay, then the second part, your x disappear. This is wrong. What you should have is you still have the 2x squared there. You still have the 2x squared, but you have to differentiate the y. Differentiate y is 1, then dy over dx, because you differentiate y with respect to x. So 8x cubed dy dx. No, it's 2y. 2y. No, no. Okay, so I write down the answer. I write down the answer. Yeah, right. Okay. So what we have here is d dx of this thing. 2x square 2x square y. 2x square y. You want to differentiate this. So you differentiate the first one. Become 4x. Then the y, you don't differentiate. You just keep the y. Then next one. Just now you differentiate the 2x squared. Now you don't differentiate. You put down 2x. 2 this is square. This is 2x squared. Then now you keep the x already, right? Two x squared. Then you have to differentiate the y. Differentiate y becomes 1. Differentiate y become 1. But because you are differentiating y with respect to x, you have to put down dy over dx. Dy over dx. Dy over dx. So finally, the answer will be 4xy plus 2x squared. squared, then dy over dx. dy over dx. So this will be the answer. I repeat. Okay, now, sorry. Okay, no, not this. I'll take the narrow one. Okay, so we look at it as two different functions. We look at it as 2x squared, one function, and y as another function. Now, the first part you differentiate become this, right? Then the y you don't differentiate, you just keep it because of the product rule, right? Differentiate become 4y, 4x, then this one keep. And the second part, you don't differentiate the 2x, right? You differentiate the y. You differentiate the y, it becomes 1. But because you are differentiating y with respect to x, you have to add this thing there. You have to add the dy dx there. So finally, you have 4xy plus 2x squared dy dx. Any question? Can follow or not? Okay. So if you can follow, then we continue with this the next lesson. So there will be no homework on implicit differentiation because very difficult the implicit one like that. So with no